Okay, let's take a look at another example using Simpson's rule. These are the limits, do 1, and then your function sin x over x dx. Question gave us that, say that there are 4 strips altogether. Okay, from here we just find the sub interval of the length. So it's b minus a over number of strips, so it's b 2 minus 1 over 4. Answer you get is 1/4. Okay, from here we are supposed to plot the table. So your x sin x over x. Okay, now we are starting from 1 instead of 0. So when we plot the graph, so it's 0, 1 and 2. And we are supposed to find between 1 and 2, not 0 to 1. So from 0 to 1, we can just don't bother about it. Okay, the subinterval is 1/4, so it's 1/4 half and 1 over 3/4. Okay, so it's like this. So for your 1, after subtracting the value, these are the answer you should get: 0.665, 0.562, lastly 0.455. Okay, once you get all this value, you can just simply sub all the values into the formula of Simpson's rule. Okay, so the formula will be okay, 2 1 sin x over x dx. Okay, formula is h over 3 y0 plus your last one will be y4. Okay, plus 4 y1 plus y3 plus 2 y2. Okay, so you sub in the value. So h you just now find is 1/4 over 3. So if your y0, you just take a look at, so it's 0.841, this y0, y1, y2, y3 and y4. Yes, so after then this the value you should sub in 0.455 plus 4, 0.759 plus 0.562, and you got to time your 2, 0.665, which is your y2. Okay, after you sub in the value and stuff, your answer you should get is 0.659.
Continue from example 4 under Simpson's rule. I'm going to show you how we're going to do this example 4. In example 4, we have to find the voltage of supply in millivolts at a regular interval of 0.01 seconds over a half cycle, and it is to be found at 0, 19.5, 35, 45, 40.5, 25, 20.5, 29, 27, 12.5 and 0. All this value on top is equal to the value at the table over here. It's all equal to the V value as stated in the table. By Simpson's rule, we have to find the RMS value of the voltage over the half cycle. What is RMS value? RMS value refers to root mean square value, which is equal to y RMS equal to square root 1 over b minus a integrate ab y square dx. And over here, the y, we have to change the value to v, which because we are finding the voltage. And over here, the dx, we have to change it to dt because voltage vary with time. Therefore, dx we have to change it with dt.
Continue for example 4. This will be the equation given by the question. And first, we have to find the value of h. For the value of h, we no need to use the formula to find the value of h because the voltage is given at a regular interval of 0.01, which means that now h is equal to 0.01. And for the value of t over here on the table, we don't know the value of t. So now what we can do is we sub A equals to T to represent the value of T, and at the subsequent value we have to add 0.01 seconds to it, as there's an interval of 0.1 seconds to it. Therefore, over here from the equation we will do part by part. First part we will do the integrate of this equation over here, f ba v squared over dt. The equation is shown over here. The value of b is equal to a plus 0.01, and we have to just sub in the value into it. Using the formula of Simpson's rule, which is shown over here, we have to just sub in the value to it. The first column over here will be y0, continued by y1, y2, y3, y4, y5, y6, y7, y8, y9, and y10. And after subtracting all the value inside this Simpson's rule equation, you will get the answer 18.433. And therefore, once we get the first part done, we will find the voltage RMS value, which is square root 1 over B minus A, FA, BA, Y squared dt. This value, where we get it, it will be 80.4633. And for the value of 1 over minus B minus A, B will be A plus 0.1, and value of A will be value of A. After we sub in all the value in, we will get the answer 28.37 millivolt.